Hey gang, so just wanted to go over something really fast. Now, last Friday was homecoming, and it was kind of crazy. So for physics, we did something a little bit fun for those who were in class. We talked about the movie The Goonies. I don't know if you've seen that before. I hope you have because it's like an '80s cinematic classic. But the whole idea behind the movie The Goonies was that this one kid, Mikey, and his friends were following a pirate treasure map, and they were trying to find One-Eyed Willie's secret pirate stash. And we brought up the idea of a treasure map and how that works. And we had a little bit of fun with it. We talked about talking like a pirate and pirate code and things like that. And that was all just kind of extra stuff to make it fun. But there was some stuff in there that was really important. So here's what I want to do is I want to take a look at this right here. So this is a map of our high school. All right. And here's my classroom right here, 318. Now, the whole idea behind setting up a really good a map is that you have to have two things, okay? You have to have, so let's do this. So we'll do maps, all right? So first of all, you need a standard system of measurement. So let me explain what that means there. So when we talk about a standard system of measurement, what we mean is that we need a way to measure things that isn't going to change. All right. One of the problems that happens when I bring up the whole idea of a pirate treasure map is people's like, oh, we're going to take steps. Well, the problem with measuring things by steps is that not everybody's steps are the same length. Okay, so what might be 10 steps for me might be like 12 steps for someone else, or 8 steps for someone else. So we've got to find something else that is uniform. All right, so normally we could do things like feet, or not like feet, but like 12 inches in a foot kind of thing. Or meters, but the problem that we run into is that when we're making a pirate's map, that's just way too obvious. So I had some people who did ceiling tiles. I had some people who did lockers, and as long as there were lockers there, they were okay. But you need to have something that is, once again, uniform. The other thing that you need is a fixed system of orientation. All right, so that's important because what we want to know is we want to know what direction we're going in. All right, so one of the problems that happens is when you start talking about like right, left, or other things like that, that can get a little bit tricky, especially if you start getting your locations mixed up. So we want to have a way of knowing where we are without, regardless of where we are. So, like for example, I think we figured out that on our map out here, okay, so this was north, all right, so that means this is south, and I remember it's never eat soggy waffles, all right, so never, so this is east, south, and this is west. Now, once again, if you're a pirate and you're trying to make this clever and make it so it's hard for people to not find, or hard for people to find things, then north, south, east, and west just isn't going to work, all right? So, like, we could use the north, south, east, west. When I lived in Utah, the way that they have their roads is really different than Michigan. I just use the mountains, okay? So I would find, if I was ever lost, I'd find the mountains, okay? The Wasatch Mountains, they ran north and south, and you could kind of figure out where you were going from there, and you could use lots of other things. But the idea, once again, is that you have this fixed system of orientation. But here's what I want to do. Let's say that we are starting at my classroom, and we want to make it all the way, let's say, to Mr. Huntley's class. Okay? Well, if I take a look at that, what would be the easiest way to get there? Well, lights just went out. Okay, I could go this way, and then I could go down here, and then I could go this way, and then I'd be at Mr. Huntley's class. Now, here's the question that I have for you. Is that the only way to get to Mr. Huntley's class? Well, there's lots of different ways. I could go, and maybe I would say, you know what, I'm going to go out my door, I'm going to head south, I'm going to go, what is that, like 20 tiles or something? I'm totally just making that up. And then I'm going to go this way, and I'm going to go out the door, and then I'm going to go around here, and I'm going to come in this door, come this way, and then I'm going to keep going here, and I'm going to come down here, and then I'm going to come this way. All right? So and I could keep doing that over and over again. The trick is, what would happen if I go and add all of these up? Like, let's say I want to look at my first route, okay? So how many times am I going north, south, or east or west? Well, here I'm going north, and here I'm going north, and also this time I'm going east. Okay, so I could figure out how many times I'm going, like how far did I actually travel north, and how far did I actually travel to the east. All right, same thing with my other route. I could say here I was traveling to the south, and then on this part I was traveling to the west, and this time I was traveling to the south, and here I'm traveling now to the east, and now I'm traveling north, and another north, and another east, and then I go south. So if I was to add up again all of the north, south, east, and west, and just kind of quantify those as how many are going north, south, and how many are going east, west, what would happen when I did this and compared the different routes? Okay, so that's the main idea that we're going to talk about with this idea of vectors, is how do we take the little itty bitty pieces and figure out where we end up. All right, we'll talk more about this soon.